Welcome to Chapter 8, Lesson 4, Multiplying Special Cases. So there are at times special rules that we can use to simplify squares of a binomial or the product of a sum and a difference. So the square of a binomial. Notice the following pattern when multiplying out these binomials. So first of all, it's x plus 4 squared. So that means I can go x plus 4 times x plus 4. And now I can use my FOIL, firsts, which is x times x, or x squared. Outers, which is 4 times x, or 4x. Inners, which is 4 times x, or 4x. And lasts, which is 4 times 4, or 16. Then I put them all together, and I get x squared plus 8x plus 16. Now, one of the things you should notice here is when I look at this one, I see this 4 here. If I add 4 plus 4, I get 8. If I take 4 times 4, I get 16. So in general, when we take an a plus b and square it, here's what happens. We get a squared plus 2ab plus the value of b squared. In other words, x is our a, so we get x squared. We take the a plus b, or a and b, double it. That's the 2ab. And then b squared is 4 times 4. Now, it looks a little bit different when we are dealing with a subtraction problem. So again, x minus 3 quantity squared. Firsts is x times x. Outers is minus 3x. Inners is minus 3x. And lasts are plus 9. So if I combine my like terms, I get x squared minus 6x plus 9. So how does that look in general? Well, we have our a squared, and we subtract double the ab plus b squared. Okay, so take a moment to look at that. Now that only works when we are squaring an item times itself. Okay, so x plus 4 squared, x minus 3 squared. All right. So then the next special case is when we have the product of a sum and a difference. So now, first scenario was I was taking the same thing times itself. This is a little bit different. Now I am going to find firsts, outers, inners, lasts. So firsts is x squared. Outers is 5x. Inners is minus 5x. And lasts is minus 25. So when I put these together, because they are like terms, 5x take away 5x is no x's. So my answer becomes x squared minus 25. So essentially, and again, you have to really pay attention to this because a lot of times I have students that want to change this rule, and that first example, they want to do that to what this is doing, and you can't mix them up. So this only works when one of them is negative and one of them is positive. Then they will cancel each other out. All right, so if I go to the next one, First, again, notice it's basically the exact same problem, but one is adding and the other is subtracting the b value. So 2 times 2 is 4, so that's 4x squared. So there's our firsts. Our outers is minus 8x, inners is plus 8x, and lasts is 4 times negative 4, which is negative 16. So once again, you see this right here. Whoops, sorry. Thought I had picked up my color. I hadn't. Well, still again, wow. On the struggle bus here today. Again, noting that one is taking away the 4 while the other is adding the 4. So when that happens, those negative 8 plus 8 drop out and it becomes 4x squared minus 16. So in general, when we do this style of problem, okay, so this style of problem where we have the exact same A, the exact same B, but one is being added and one is being subtracted, what happens is we can simply take the A value and square it, and then take away the B value squared. Because those middle values, the inners and the outers, are going to essentially drop out. All right, so here's what I want you to try before class. So pay attention. This one is this squared. So basically that means I'm going to take A, take away 8, times A, take away 8. Nothing is going to drop out of this one. But notice this one, that will have the middle part dropped out. Now, number 3, find the area of the shaded region. Hint, find the area of each square and then subtract. So you're going to find the area of x plus 4 squared, and then you're going to subtract x squared. And what you get then will be your answer to the area of this part that's shaded in yellow. All right, good luck. We'll talk about this the next time you come back to class.